Page, I don't know, 76 or something? 77. 7 plus 7. All right. Okay, ladies and gentlemen, please listen. This unit is incredibly heavy on vocabulary. All right? There's a lot of new words that go with the new concepts in this unit. And of course, I do not tell cute little fairy tales about math. I call the stuff in math what it is by its name. So that name gets into your math lexicon. So you use the words properly. So when you go off to other teachers or other math programs, you do not sound like a doofus. Because I care about you. Okay? Let's go. I know, right? The first new word is set. Is your first word set? Yes. Okay. A set is any... Oh, I don't want the thick blue pen. Any group of data. Data is simply information. In math class, it's information we can count. So a set is any, or I should have said any single group, but I didn't put an S on group. Any group of data. Everybody understand? We'll start with a real easy one. What is a set that we could apply to this classroom that would cover every single person in it? There you go. How many people are in the room? Right? Easy peasy lemon squeezy. Can we break that set down? All kinds of ways, yes? Yeah. We could break it down between adults and kids. We could break it down between what else and what else? Gender, race, age. We could break that down into how many sets could we have? No. There's only 30 people in the room, right? Could we find something unique about each of us in the room so we were in our own set? Everyone understands this, yes? Ease, bees, lemon squeezy, right? Okay, so everybody's get it? The key here is it is any group, as long as we can count it. Could there be a set of nothing? Yes. It's an interesting question. I like what Ron says. You can't count nothing. So could we have an empty set? Yes. Right now, is there anyone in this room that is a grandmother? No, dude. There isn't. But could we bring in Miss Varnes, who does have grandchildren? Miss Varnes. Never mind. Okay. If we brought in Ms. Verk, would we have a grandmother? No, because she's like 25. Everybody understand? Yeah, it's tough to do this course with grade 10s because you've only had like 8 teachers in the whole school. It works better when I'm teaching grade 11s and 12s because they've had a bunch. Everybody cool? Okay. The next new word is an element. An element is a single piece of data, which means sets are made up of elements. Everybody cool? So a set we could use for this room, people in the room. Each one of us is an element of that set. Do you understand? Assuming that none of us are indeed aliens from another planet sent here to Yeah, I know. I got to be quiet about that too. They really get mad at me when I start to mess with my cover. Everybody good? All right. And finally, a relation is anytime you compare elements of one set to elements of another set. Right? Easy peasy. So, in this room we have a set, we have people, yeah? There is however many of us there is. I'm not going to count. Let's say there's 29 of us in the room today. Right? Next door, is there a set of people? They're a set on their own. We're a set on our own, yes? But if we compared the two, we would be making a relation. Everybody good? Right? Okay. So maybe there's another adult in Mr. DeVries' room right now. That would change things, yes? When we compared the two, because in here there's only one adult. And even that's arguable because, I don't necessarily behave properly all the time. Everybody good? Easy, right? Okay. So now let's apply this to a situation. Before I go any further, actually we'll do that afterwards. Let's talk right now. This graph, is this graph a set? Pardon me? Yeah, there we go. This graph is not the actual set, is it? It is a picture of the data, right? If I say, read this graph to me, you all can read all those types of dogs. Some of you will know what some of those dogs look like. Is there any dog in this room? No. So a graph, oops, I want to change color. A graph is a representation. Please highlight that. A representation of data. It is not the data itself. Everybody understand? Data is information. It cannot lie. Graphs represent data. They can lie. Does everybody understand? Yes. Which is why whenever you see something on the news or in some political guy's flyer for why you should vote for him, they don't show actual statistics. They show graphs. Why? Because graphs can be made to look like they fool you. Everybody cool? All right, and we'll do some of that today if we have time, and it will make you laugh what you can do with graphs. All right, so we've got a representation of data. Now, if it represents data, a graph must have sets, correct? And sets are groups of data, yes? So how many sets can you see in this graph?
1, 2, 3, 4, 5, 6. 7.
A set is a group of data made up of elements. How many sets do you see?
1.
Set 1 is what? Dogs, right? So set 1 is dogs. What are the elements of that set? Are hound, chihuahua, which I would argue barely should be called a dog, but whatever. Corgi, lab, shepherd, malamute, right? The set, and what color did I color set at the top? Who remembers? Is it yellow? Green. So the set is dogs. The elements are the types of dog. Everybody cool? That is one set of data in this graph, yes? What is the other set of data in this graph? What is the other information this graph presents us? Gersil, height. And that is, of course, green because that's the set. And what are the elements of that set?
10, 20, 30, 40, 50.
No. No. No.
60.
There you go. 60.
11.
So 60.
More than 10.
11, fine. 30.
40,
45.
2.
Whatever. 45 and
45.
That's one higher.
80. Everybody cool? So right now, I have two sets on a graph, yes? Do I have a relation yet? Have I compared the two? If I ask you this next question, how tall is the average hound? Have I made a relation now? Why, Jade? Why does the question, how tall is the average hound, make a relation? You've got the definition of a relation there, Jazreed. Yes, I am taking an element from set 1, which were hounds, and I am comparing it to set 2, which is a height. Is everybody good?
Pretty much.
Okay, so it becomes a relation, which I believed I used blue for. It becomes a relation when I compare the two. Now, where do you see a problem? How tall is the average Chihuahua? 11, right? What dog has an average height of 30?
Corgis.
Right? Easy peasy, yeah? Okay. How tall is the average shepherd?
45.
Okay. What dog has an average height of 45?
Lab.
Wrong.
Shepherd.
Wrong.
Both.
Which one am I thinking of? You can't know. Why?
You didn't tell us.
Because we don't have the word superpower.
Wrong. But you're right. You don't have the world's worst superpower. Why does that screw up this relation? When I say what dog is 45 centimeters tall, why does that screw up the relation? Gersil.
This graph only shows the average, not the exact height.
Nope. I'll do it again. What dog is 60 centimeters tall? What dog is 11 centimeters tall? What dog is 30 centimeters tall? What dog is 80 centimeters tall? What dog is 45 centimeters tall? Which one am I thinking of?
We don't know.
Why?
Because you haven't told us.
No.
You haven't.
Because we don't know because both.
Stop doing word.
Because they're the same.
They're both
Jade is right. You can't, I know, right? It's not. 45 applies to two different pieces, two different elements, yes?
Yes.
So you cannot tell me which dog it is I am thinking, of which I am thinking, yes? Okay. So everyone's cool with that? What's not cool with, why do you not understand that, Jacob? Or Jaden?
because they're both the same.
They're both the same, so you can't know which one I am speaking of, right?
They say we don't know.
You can't know. It's not that you don't know. You can't know the one I mean because this relation could go this way, couldn't it? Lab to that 45 and shepherd to that 45, right? Everybody cool with that? So, if I take lab and shepherd out of this, now you always know what dog I'm talking about, right?
Correct.
Always.
Yes.
Because if I say 30, I'm talking about a corgi. If I say 11, I'm talking about a chihuahua. But if I add those guys back, I'm in a bit of trouble, aren't I?
Yes.
Right? Okay. That's the next thing I was going to ask, almost. No, you can give me away now. What if I only add one of them back?
Then you know
You're still okay, aren't you?
Yeah.
Okay.
Could you add lamb and shepherd or like
If I wrote, no, that's a good question. If I write lab shepherd, that makes one element, doesn't it? Are they the same? No, they're different kinds of dogs, right? We could talk about it that way, but if we were going to mathematically graph it, we would need to have separate pieces of separate elements. Cool? All right. Everybody's good with that? Okay. So, soon as I ask, what dog is 45, I've made a relation, right? Right? Okay. Turn the page over. We're going to get to our next new word. Function. Now, this causes great consternation amongst my students. I don't know. When you see the definition, you all are so intelligent. You'll be just like, duh. And Jade will say, it's not rocket science, like I do. So, what do rocket scientists say?
it's probably rocket science.
Probably. I guess they say it's not brain surgery. But then what do brain surgeons say? It's not rocket science. And then everything works out. So, a function is a particular type of relation. So, listen to me. I'm going to stop for a second because when I write the whole definition, it confuses kids. A function is a type of relation. So, is a relation automatically a function? No. Functions are a specific and special kind of relation. Everybody cool? And I'm going to explain that more in depth in a minute. But you need to understand, all functions are relations because you're comparing two things. But not all relations are functions because functions are very special kinds of relations. Everybody cool? All right. A function is a particular type of relation in which each element, thank you, Emma. So, every piece of data in one set, if I'm making the branches like I made here, would only go to one element in the second set. Everybody cool? So, we're going to talk about this right now. Each month of the year relates with a number of days. So, what is the first set in that sentence? What is the first piece of data? Garcia. Months. So, set one is months, right? Is that the set or the elements? That's the set. What are the elements of that? January, February, March, right? January, February, March, April. And we can stop there because it's going to prove my point. What is the second set?
Number of days.
Second set is number of days. What are the elements of that set? No. Number of days. You can have a month that is how big? 30 or 28 or 29 or 31. Everyone agree? Everybody agree? Those are the only options for number of days in a month, yes? Okay. January has how many days?
31.
31. Is that a relation or a function right now? Does one element compare to only one element? Right? So it's a function right now, yes?
Yep.
Okay. What about February?
It could be 28 or 29.
28 or 29. Now this gets a little trickier. If I say I am thinking of the month with only 29 days, do you know the month I mean?
February.
Right? So is it still a function? Do you automatically know what month I'm thinking of if I say that? So even though the February goes to two different numbers, is it still a function? It is. Because we can work backwards and forwards, right? How many days does March have?
31.
31. Did you just check on your knuckles? That's how you count? Yeah. March is 31. Is it a relation or a function? Now it's a relation, right? Because if I say I'm thinking of a month with 31 days, you know the month I mean? No. Everybody cool? So this is a relation. Why? Because certain months have the same number of days. Everybody cool? Everybody cool? Yes. All right. So let's look at the next one. Every name on my class list relates to a student in my class. What is set 1? Set 1 is names. Everyone agree? Okay, what is set 2? The actual people, right? Okay. Now, names is a tricky one to use, right? Because we could go by first name, we could go by last name, or we could go by both names. Agreed? For our purposes, we're going to go by first name, right? Everyone agrees?
Yes.
Cool? Okay. So there's 30 names in the class, right?
Yeah.
All right. That person right there in that desk is kid 1. Everyone okay? So let's make the relation, right? Kid 1 sits there, and I'll use green for that. That is kid 1. What is kid 1's first name? No.
I don't know.
Anmal. Everybody cool? What is kid 2? Rylan. Because that's a relation, right? That kid is a real kid in my class, and that kid has a name on my list. Agreed?
Yes.
Everybody cool?
Yes.
Now, when does this screw up?
With our name.
Braden's and Anmal's. Because kid 1, 2, 3, 4, 5, 6, 7, 8, 9 isn't Anmal also the name of, damn it, kid 9? And 9, 10, 11, 12, 13, 14, 15, 16 isn't kid 16, 17, 18, and kid 18, both Braden. So, is this a relation or a function? A relation. What if I go by last name? Does anybody in this room have the same last name as anybody else? No. There isn't.
Wait, they both have last name.
But she is Smith Molina. If we went by last name, is it a function or is it a relation? Function. If I went by first and last name, it is almost always going to be a relation, yes? Except in 1 year where I had 2 Jaspreet Gills. And they even had the same middle initial.
That's weird. I bet it's K.
It was a K. No, it was Jaspreet Dillon, sorry. I can't remember who it was. Anyway, they were the exact same first name, last name, and middle name.
Was it the exact same middle name or just initial?
Huh?
Was the middle name the same?
The middle name was the same. They were exactly the same 3 names.
How would that happen?
It's not that hard.
Was there so many names?
All right, is everybody cool? So this one is a little tricky, right? So in our room, if we use first name, what is it? It was a relation. What if we use last name? It's a function. Everybody cool? Because if I say to you, I am thinking of the name of, if I say Braden, and I go to my list of K through 6, or K1 through K30, do you know which K I am speaking of? If I'm speaking of K16 or K18? No. And you could never know, could you? Right? If I said I'm thinking of Anmal, am I thinking of Kid 1 or Kid 9? You don't know. Everybody understand? Okay. Now, we have to add some layers to this, don't we? Because, like the month thing, if I say 30 days, it could be March, April, June, September, November, right? But if I say the month name, do you automatically know how many days are in it?
Yep.
So we have to add a wrinkle here, don't we? Because it's not enough to say they go back and forth, right? Because think of the dogs. If I said, how tall is a shepherd? You all would say 45. But if I say, which dog is 45? You can't tell me, right? So we have to add another layer to this. Let us do that right here, cabbages. Bathroom time? Of course it is. Right when we're doing something new. Exactly the right time to leave. Independent variable and dependent variable. What in English does the word independent mean?
By itself.
It is by itself, right? Needs no support, right? Dependent means you need something, right? So, first of all, let's talk about variables. Everyone is going to yell the wrong answer right now. What is a variable?
Something that can be anything.
Unknown is good.
Something that represents another thing.
Getting warmer, that's a symbol.
Something that can be whatever.
X is totally wrong. But everybody says it, Braden. Don't worry about it. What does the word variable mean? Not.
It could be anything.
It can be anything. It can change. Okay? That's what variable really means. It is any value which can change. So if we're talking about months of the year, there's 12 variables there, isn't there? Right?
Well, how?
Well, there's.
The month.
Okay, I'm thinking of a month of the year. There's 12 of them, yes?
Yeah.
So that changes,
Yeah.
right?
Oh, sorry. I thought you meant days.
Okay. Everybody cool? Well, even days changes. Because it would be either 28, 29, 30, or 31. The number of days,
That's why I got it.
yeah.
You said 12.
Okay. The number of days also changes. Anything that can change is a variable. All right. So an independent variable must be a value that can change, right? But needs no other support, which is kind of hard to explain if you do that one first. But it's a little easier to explain if you do the dependent variable first. I'm not going to write down any definitions. I'm going to talk about it and see if you can help me out. See if you can figure it out. All right? So we'll use our months, or we'll use our names and kid, right?
Yeah.
Okay. I labeled Anmal's desk as Kid 1. Agreed? And Kid 1's name was Anmal. Everybody cool? So the variables involved here are all the first names in the room and all the desk positions, right? Okay. If Anmal moves to Jade's desk and Jade moves to Anmal's desk, is Kid 1 still Anmal? No. So which of those, Kid 1 or the name is independent. Which one doesn't change? Kid 1 doesn't change. Whoever is sitting in that desk has a name. The name of that kid depends on the kid sitting in the desk. Does everyone understand? Okay? So, the independent variable is the variable which we can always define. Right? As long as there's a kid in that desk, that kid has a name. Right? Right? So the name depends upon the kid that's there. So the dependent variable must be, not the variable. I'm not, a bad Russian villain from the 1960s. The variable. The variable which can only be defined by the independent variable. In other words, you don't know the name of the kid in that desk until you see the kid in that desk. Do you all understand? If I were to turn around, hide my eyes, and tell somebody else to go sit there, I would not know whose name that kid has. Right? Everybody's good? Okay. Now, I'm going to use the same color here. Domain, range. Independent variable is yellow, domain is yellow. Why?
Is this the same thing?
They work together. The domain, and this is where it gets tricky, is the set of elements which make up the IV, independent variable. All right? So our independent variable was kid in the desk, right? So if there's 30 names on the list, my domain is 30 different values, right? Kid 1 up to what? Kid 30. That's my domain. Does everybody understand? Because we decided, we understand why, that the name depends upon the kid in the desk, right? Okay. So what's obviously range then? Right, the set of elements which make up the DV. Now in this room, how many names is that? No. 28, because we've 2 Anmals and we've 2 Bradens, right? Yeah. So there is name 1 up to name 28. Is everybody with me? Yeah. All right, let's see if you're really with me. Page 79. Sandy is getting a job at Flying Wedge Pizza, which no longer exists in Abbotsford. It's too bad because Flying Wedge was super delicious. She is being paid $9.50 an hour. I'm going to change that to make it easier on us because you people have been so good. She is getting paid $10 an hour. Her work hours are related to her pay per week. So, identify the IV and the DV. IV, DV. Which one of those is independent? Which is it? Well, we've talked about it. Independent is the one that has to live by itself, yes? So ours is independent. Why? Because her pay depends upon the hours worked. Does everybody understand that? If I don't go to my job, do I get paid? I am on a salary. Good call. If you are paid by the hour and you do not go to your job, do you get paid? No. Do those hours still pass? Yes. So your pay depends upon your hours. Everybody understand? All right. Now, let's identify the domain and range. Which of those is the set that would be domain? Hours or pay? Hours is domain. So our domain is hours. Right? And now we've got to identify what it is. What's the least amount of hours you could work in a day? 0. Right? Oh, it's pay per week. Sorry. What's the least amount of hours you could work in a week? 0. Now let's say, for argument's sake, I know this is not true, but I'm trying to teach math. She works at her job full time, which means how many hours per day? 8. Yes. How many days a week could you work? No. 5. So the domain, she could work 0 hours if she doesn't work at all. What if she works 1 day? 8. 2 days? 16. 3 days? 4 days? 5 days. So those are the only hours she can work because her boss only schedules 8-hour shifts. Does everybody understand?
Yes.
Excellent. So in math, once we have a set, we put these squiggly devil horn brackets around them. It's that bracket that in emojis makes the devil horn. You don't have to be able to draw it, Vera. Just make it squiggly. I'll know what you mean. Everybody cool? What is our range then? It's her pay. So if she works no hours, how much does she make? 0. What if she works 8 hours? 80. She gets $10 per hour. Then what? 160. Then what? Then what? Then what? 400. And it's a squiggly bracket. Does everybody understand? Everyone's good? Now, is it a function? In a function, every IV or domain value relates to how many range values? 1 DV or range. Is that the case here? Say a value from the domain. Any value from the black list. From the black list, a domain value. 24. Does 24 relate to 1, 2, 3, 4? To only 1 range value? So is this a function? Yes. So this is a function. Yes, because each domain value relates to 1 range value. Everybody cool? Easy peasy lemon squeezy, yeah? In real life, it's easy to see it, right? Because hours depends, or pay depends on hours. It's easy to see. What's different about number 4 here? Is it real life? Any more? No, that's just numbers, right? What does, and you need to think back to grade 9, what does that notation mean? When you have bracket, number, comma, number. They're X and Y's, right? How does that work? How do you find this point? What's first? X. So you would go out the x-axis, say this was 3, 5. 1, 2, 3, and then what?
Y.
Up to 5 on the y. So x is our independent variable. Y is our dependent variable. Everybody cool? So what is our domain here? What are our x values? 1, 2, 3, 4. No, it stops at 4, right? So x, and then we put a straight line. Those are all our possibilities for x. What is our range? Now notice, 1 went first, and then I went 2, 3, 4. What order did I put them in? Numerical order. So what is our range? Our y values are what? What's the lowest y value we have? 3, 6, 9, 12. Agreed? Now, once we split them up, we no longer have this pair anymore. Everybody cool? Now we have range values and domain values. They're separate. But let's check. Does that range value, that domain value, link up with only one range value? Does it?
No.
If I say 1, I can only mean 3, yes? Because of this pair, 1 and 3. What about 2 and 6, 3 and 9, 4 and 12? Are they all unique? So is that a function or a relation? That is a function. We know why. Because each IV goes to a unique DV. And this, ladies and gentlemen, is how we write. What color did I make domain with my highlighter? Domain is yellow, range is green. That is how we write the range. My pen has started skipping, of course. And that is how we write the domain. Is everybody cool? All right, let's look at this one. It's slightly different. My pen's not working very well. So, what is the domain?
No. Negative 1.
You guys try and sort that out while I get my pen